mentor is all about improving how you approach problems. Not just coding, but how you think, break things down, and actually solve them. Now, just to give you a quick idea of how this program runs. Across all sessions, learning is always followed by application. After each session, there will be a quiz based on what you learned during this session. Since this is our second session, you'll have your second quiz today. Similarly, the remaining two sessions will each be followed by a quiz that will open right after this session. At the end of the program, there will also be a final quiz covering all the topics discussed throughout the series. After each quiz, we will share a leaderboard so you can track your progress and see how you are performing throughout the program. Your final score will be based on both consistency and performance. 60% comes from the 4-session quizzes and 40% comes from the final quiz. And based on your performance, you'll earning shareable digital badges. That includes Apex Performer for the top overall rank, Distinction Performer for top performers, Consistency Performer for those who stay active throughout all the sessions and quizzes. All right, moving on to today's session. It's my pleasure to introduce our speaker, Mr. Harsha Weerasinghe. He is an experienced technical lead and an Azure certified solutions architect with extensive experience in cloud architecture, software development, and project leadership. Throughout his career, he has worked on designing scalable cloud solutions, leading cross-functional teams, and delivering innovative technology solutions across various projects. We are really glad to have him with us today. Please join me in warmly welcoming Mr. Harsha Weerasinghe. So, without taking more time, I'll hand it over to him. Over to you, Mr. Harsha.
Yeah, thank you, Asra. Hope I'm audible properly.
Yes, Mr. Harsha.
Okay, so again, thank you all for joining, and again, thank you all for spending time on learning not just the academics, but also participating in these kind of hackathons as well. Because I'm from the industry, and one of the things that I look from a candidate that I'm trying to, join to my company is not just the academics, but all your insights on participating these things, whatever you learned, these things. So I think Astra gave a explanation about myself. Yeah, I'm working as a technical lead for Wedintra, which is a US-based company. So in my career, I've been on-site and off-site in the US, designing and facing, client problems a lot and giving solutions to them. So the topics that we're going to cover today, when I was having the discussions with Damitri also, mainly I know that this is Algo Ace. I don't want to derail from the this algorithm building / hackathon slide, but I really want to explain you how we are using these algorithms, these fancy names, the hash maps and all these names inside the industry, because whenever you are coming to the industry, no one will tell you to use a hash map, or no one will tell you to use sliding window technique or anything. So all these things are inside or embedded inside. Sometimes it's encapsulated within the functions, or sometimes if you're more into system design, yeah, you might use these theories directly. But mainly what I want to show you is the theory, practical, and I do have few sessions that I want to debug with you as well while sharing my screen with the breakpoint approach. So I can give you the theoretical plus practical idea on how these things are going to work. So let's go ahead and start. I'm going to share my screen and let me know when you see the presentation. Yep, I hope you can see the blue and
Yes,
white.
Mr. Harsha. Yes.
All right. Okay, so the hidden algorithms behind real systems. Yeah, hidden algorithm is the one that we're going to discuss, but what is a real system? So that's what we need to learn, how we are going to make a system real. So from my terminology, I would say the term real is very vague, right? So someone can say a real system is a mission critical system. Someone can say real system is, something has this many users. But for me, it's not just the functionality. It's not just being bug free, but also I'm a big fan of implementing non-functional requirements. Performance, scalability, reliability, security. So when it comes to scalability, reliability, and performance, yeah, the hidden algorithms, it's doing a big thing. You should know what to use and when to use to solve what business problem, because everything we are trying to, resolve with IT, it's a business problem. So that's why I want to convert this conversation. So let's go ahead and start. So I'm directly giving you first whether we are going to discuss what we are going to discuss, frequency counting using hash maps. But before we go there, I want to explain some stuff that you already know. So let's start something that you already, that we all used. If you don't know, I'm pretty sure you know what is Spotify as soon as you see the green and white logo. But there is something called Spotify Wrapped. So this is actually at the end of the year, Spotify tells you like what are your top 5 artists, what the most played song, most played genre, the total listening minutes and stuff. So now it gives you this insight while Spotify has over 600 million subscribers or users that's actively using. So again, I'm not going to repeat the slide. You can read it while I'm going through it. But what I want to emphasize here is if for every song you play, every skip, every replay, Spotify counts this in its backend. So no one is going to sit there, right, manually tallying. There's no account manager saying, okay, this manager is for you. So everything's happened within an algorithm. So they're using a pattern called frequency counting. So that's what we are going to look into. And let's see how this frequency counting is going to go into a hash map. And I'm not sure whether you're from first year or the fourth year, but for now, just wear the hat saying you just started your, what do you say that? Before the first year, you have your, that particular time, after you finish your A levels, you don't know anything about IT, wear that hat. So that'll be very easy for you to, start mapping these through. If you already know the concept, just think this as a review session. So we're going to break down how this Spotify Wrapped works under the hood. So think if you are not going to count without any tools, now we all know that we have all these hash maps and all these optimized algorithms, but I want you to feel the pain of not having it first. So forget about Spotify. Just think that you have, imagine your data is a giant pile of receipts. So you have a million of them mixed up, and now your boss wants to know how many receipts belongs to each customer. Just again, forget about ID. Just think of you're doing a small internship in your shop or you're working for your family, you have a small shop. So now you have lots of receipts. You want to, it's mixed up. You want to sort this. What are the items belongs to what customer? So the easiest way, what we have to do is, right, it's like cleaning our table. You take one receipt, you have to sort it by one. The first receipt belongs to John Doe, second one Jane Doe. You pile this up simply. And then you pick the next customer again, search again, and then you can see how insane that it can get. So this is exactly what bad code does. So if you go through the numbers here again, I'm a fan of this talking about millions of rows, okay? Because in the industry, we are not talking about hundreds or thousands, we're talking millions. Because the naive approach is for every customer, you scan 1 million rows and count their orders. If you have 10,000, you scan 1 million rows, it's 10 billion operations. So now forget the part where you are doing this manually. Even with a system, it will be dead slow, unsustainable in production, unusable in production. And this is the biggest complaint in the industry what we are getting. Some customers say after the deployment or after the release, it worked for the first 3 months. And from the 4th month onwards, it starts slow and, randomly going time. It's showing timeouts and stuff. So that happens with the data, because now we're going to start, counting data. So is there a smarter way to do this? And we all did this. If you look at the image that I have saying Monday, Tuesday, Wednesday here, this thing, like we learned this in grade 5. So it's the same concept we are talking in IT called frequency counting. But now the difference is we have to tell our computer, we have to tell the machine that this is how we are going to count your data. So this is embarrassingly simple once you see it. Instead of going back and counting for each customer separately, what if you went through your data once and just, one by one, you just do this, 1, 2, 3, 4, and 5th one, you just cut it off. So this is frequency counting. It's just one pass. We are having a running tally. Tomorrow, when we have a new customer, what we take is we take the receipt, we mark it, and then we keep a tally. So every time we update our count. So again, very simple, but we know that it's very simple because our brain does the calculation for us. But the trick is how we're going to tell the computer to do this in an effective way, because today you might do this for 10,000 rows. Tomorrow you may have to do this for 1 million rows. So now the speed matters as well. So key properties of this approach is simply you just do a one pass through the data. So instant look and update. So, and this works for any size of data. And this is what we are going to use virtually in every real world data system. So the data structure that makes this possible is what we call a hash map. So that's what we're going to discuss today as one of the concepts. So it's the same thing as this cricket board, like scoreboard. I just realized that I added a very bad score, even though we have the best players at this time. I should have replaced it, but it's fine. So think of like a tally board at a cricket match, right? Because let's say now we are counting. The operator doesn't watch the whole match and then calculate the scores at the end. They update the scoreboard ball by ball and run by run. So they should not miss it in the middle, because if someone can ask like, okay, what if you miss the count in the middle, then the whole process messes up. But with frequency counting, what we are doing is we are not calculating every time. We just keep a running tally. So again, if still for you, if this still feels like it's a simple model, even last week, I happened to face this kind of a scenario where one of our clients reported saying, one of the reports is again timing out. So the quickest solution that I had was, why don't we, every night we run a job. So this particular report that we have, it's actually daily we have to calculate some of the operations that our client is doing in their machine. So the first thing came into my mind was, okay, every night, why don't we run a job? For yesterday, we calculate all the data in the midnight, because in the midnight, the server is not busy. When I talk about the midnight, it's Sri Lankan time, it's morning. For them, it's night. So whenever someone opens the dashboard, I'm just showing the calculated value, then calculating every time when a user sends a request. So that's one way of doing that. And the second way is the frequency counting. Yeah, every time when someone does an operation, yeah, we update our variable that we are storing somewhere. So the difference between the methods that I just mentioned is, if you update it every time, like frequency counting, you will get your data, like even in the next hour, you will get the most updated data. with the operations that we did within the day also. But if you go with that pre-calculated approach that I mentioned in the first place, I'm only getting data of the yesterday or day before yesterday because I'm running this only one in the night. So again, coming back to this, yeah, scoreboard operator, every ball, they mark it while the match is happening. So you process each piece of data immediately and you update the scoreboard. And you have to update the scoreboard immediately as well. Now, this is what I want you to focus. Hash map is your scoreboard. This has everything. The player's name is the key. If you see Sanath Jayasuriya scored 23, Sanath Jayasuriya is the key. The run count is the value. Value is 23. So that's the mental model I want to show. And then no recounting needed because someone already calculated it while it's running. So again, it's insanely simple if you think of cricket, right? You don't think who is going to, recalculate everything by looking at a board. I mean, that's what a scoreboard is. Again, it's very simple for us because our brain automatically knows why don't we do this. But for computers, we have to tell them or we have to train them to do what exactly our brain is doing as well. So that mental model is the hash map when it comes to a computer. So what is this hash map? We call it the data structure behind counting. So now we are coming into our IT terms. Most of the data structures make you search through them to find something. We know about this bubble sort, selection sort, all these things. We are searching through them to find something. It's like, going through pages in a book. But hash map, it's not going to search, it's calculating. So what happens is whenever you give it a key, now in our scenario, I just told you in this scenario, player's name is the key. Think of a inventory or some kind of a sales system. So let's say you're giving a customer ID as the key. So it runs a mathematical function and it's on that key and it gets a memory address. So it directly goes there, no searching or no scanning. So it's just a lookup. So since it's a lookup, even it's 10 items or 10 million items, you can simply look up the data and get it. So internally, the hash map is a key valid pair. We also call it a dictionary or an associative array, but I have never heard, very little time I heard this word associative array in the industry. We always use the word dictionary. So we are using these, storing this data as key valid pairs. The key is the name and the value is whatever the value. So why it is hash? Why we are saying, you can read through this. Every key is unique, each key maps to exactly one value because otherwise you will get duplicate data. So the word hash is internally, it converts your key into a number using a hash function. So if you don't know what a hash function is, you can read it through. So it's just a encrypted value. It's a hash function. So that number tells exactly where in the memory to store or find the values. So what we will do is, let's think of a scenario where this order processing system, I have a customer. I want to see how many orders placed by this customer. So every time when this customer is going to place an order, first order, he places it. So if I want to store the count, I just get the ID and then I'm storing the value as 1. Second time when this user places an order, okay, it's 2. So it's automatically counting, and whenever I want to get the count of the orders, sum of the orders or count of the orders, I just go to this particular memory location and grab the value. I'm not counting the old orders or anything in a table and get it. So this is why it's so fast. It's not searching or it's not seeking the value. It calculates the location directly. So this is exactly now from the core logic in pseudocode. So I'm trying to present everything in pseudocode because sometimes you might specialize in different languages. So I'm not a fan of sticking to one particular language, but even though I'm saying that, I'm targeting this series with SQL and C# as well. Both you will see when I'm going through the next slide items, because I wanted to again show you where I saw this hash maps and stuff being used in the industry properly. So let's go through the core logic here. So three things are happening here. Just always, map the check, update, and initialize. So these are the main things that's happening in a empty hash map. So first we set up, and then let's say we have for each item in my data list, if the item is already accessing the key. I do have another proper example, so I'm just going through quickly here, but the internal code will look like this. So if the item, I do have a list, if the item is already exists as a key in the frequency, let's say our customer ID. We have 5 customers. Let's say the first customer comes, places the order. I will have 5 items in my list. And when I say for each item, this is a loop. So it's going to go through, it's going to traverse through all 5 customer IDs. So first I'm getting my ID. I'm checking whether it's already exists. If it's not there, if it's not going to our if condition, it goes to our else condition. So I'm just saying, okay, this is the first time I'm seeing this item. I'm going to start counting. And then, is it going to return? No, because it's a for each loop. You'll go to the second iteration, take the second customer. Again, let's say the same customer places the second order also. Now it will go to our if condition because now we already have that item in the key. Because here what we're checking is if the item is already exists in the frequency. So I'll show it from this one. So let's say you're developing an e-commerce site. Let's say something like Dara, something like AliExpress. So you're developing the admin panel and you want to see how many times, what's the most demanding product, okay, what's the most weaving product in a particular time. When it comes to market trends, sometimes when it comes to Valentine's Day, there are particular products that people start, watching a lot. When it comes to Mother's Day, Father's Day, so there are specific items, right? Like when it's, so in this scenario, let's say I have this list in my inventory. I want to see how many items this product was with. So first of all, based on our algorithm, my algorithm starts running. And first it's processing the product called laptop. So it's not seen before. So we are initializing our array. That's the same exact thing we did here. It's going to the else part or every time when it comes to the first one. So action taken, not seen before in the array. Just think that we are looping here. I'm telling, okay, laptop is now built. Now again, another person comes and is going to look at the phone page. Same thing happens. Not seen before, we are initializing at 1, but now our array updates as we saw the laptop 1 time and the phone 1 time. Third iteration, another person comes or the same person comes, whatever. Again, looking at the laptop, our third 0, 1, 2, our second index. Seen before, okay, now your site updates its update count saying, okay, laptop, now we saw it 2 times. 2 people reloaded our page, or just, different person came and checked the page. Again, tablet, a brand new one, not seen before. Now tablet is 1. Phone, yeah, we had it earlier. In step 2 again, now here, think of the scenario where you have a hash function for your phone. It's going to update its memory address because we just discussed. It will either check, now update. If both the things are not there, I mean, always in the first one, it's going to initialize. Fifth one, again, phone. Yeah, we saw it. Again, laptop. So now the wave count update saying 3, 2, and 1. Again, phone 3, 3, 1. So now think of a scenario where if you are not keeping this kind of a running total, how we are going to solve this problem? Again, let's go back to our practicals. If now you need to develop a function, you want to show in your dashboard to your sales manager saying these are the most viewed products, so they need to either restock this, they need to do marketing campaigns, whatever. So 2 ways to do this. One thing is every time person reloads a page, you have to put a log entry saying, okay, someone viewed this, someone viewed this. In this date, this person, timestamp, whatever. Second approach is the hash map way that we are currently doing, which is keeping a running total. Now, whenever you are reloading your dashboard or someone opens your dashboard page, if you go with the first way, you have to scan all the rows that you added in your database and count, right? If you're working with SQL or MySQL, you have to do a select count all, because now you need to count each and every entry to get this view count. So that's an extensive operation, because counting means, again, you will have a where clause if you have to do an operation there. Or if you go with the second way, hash map way, if you're keeping a running total, it's just getting the selected one value from one place and displaying. So which one is the least expensive? And when I'm using the term expensive, we are kind of talking about money, but I'm talking about the cost of execution, cost of network, whatever the memory, CPU, everything. So with the hash map, you just get the value from one place, no calculations, not going through each and every record, not going through yesterday, within yesterday, what happened, within today, what happened. You're not going through anything. You are just grabbing a value and showing it in the dashboard. So now imagine the same scenario with 50 million rows in an e-commerce clickstream data. So same algorithm, same logic. If you are keeping a running count, that will be the most efficient way. The time complexity, this is exactly what I'm talking. I want to make sure you appreciate why this technique matters, not just how it works, okay? That, from this big O notation, I'm pretty sure you know about this. I'm not going to explain this O and O1 stuff, but if you go with the naive approach with nested loops, the first way that I was talking, going through a bunch of rows, for 1 million records for 10,000 customers, it's 10 billion operations, and it's not feasible. But if you're going to use a hash map, just one pass, for 1 million records, just 1 million entries, 1 million calls will be there, 1 million operations will be there. So that's the feasible way. So at real production scale, this difference means a lot, because we are facing these kind of situations sometimes. Customers, the funny thing about this thing is whenever customer says our report is slow, the next thing you are going to get an email from them is, because of the report went down, some of customers have their own customers. They couldn't access the report and they didn't pay for us. The customer is not paying to this bigger customer, parent customer, who's paying the developers, who's paying the software firms. So the worst case is, they're asking for a refund. And these are the real world problems, okay? You will feel like, okay, it's just a timeout. It's just 10 seconds, just 5 seconds, but the impact is huge. So that's what I want you to learn when you're coming to the industry. It's not just a technical concept. everything has a business value, money feature tied to it. So it's very important. It's not like, final year project, the report takes 5 seconds extra. No, sometimes these organizations that we work with, they have different, some other organizations who's auditing the softwares that we do. And if this audit firm says the website, the dashboard page took 3 seconds to load, but the accepted criteria is 1.5 seconds, the compliance might say, okay, we should not give this software, this development to this software firm. So again, the story is, it's not always computation, everything ties to money, everything ties to business contract. So the decision that you are taking here, whether you use a hash map or sliding window technique, it's doing a lot when it comes to business as well. So if you're going for an interview tomorrow, you have to have any interviews, talk about these as well, not just the technicals. Because, again, I'm going away from the slide, but with AI and, you all know that. And again, I don't want to tell you that, development will be there as the same phase. The bots will start coding, Cloud Code, Gemini, ChatGPT, these things will start coding. You should know the business part of it as well, because that's the skill that AI cannot replace. So know the tech concept, try to map it to business. And next time when you're going somewhere, going to an interview, if you can say, I'm going to use this particular technique because this might ultimately get us a new job. We can convince the customer saying, you can sell this to your other customers because of the speed difference. I mean, that's what I'm looking for. That's what organizations look for these days. So broaden your knowledge, not just tech stuff. So again, coming back to coding, the common mistake, the bug everyone writes the first time, and I have to be honest, even Cloud does this. I saw this 2 to 3 weeks back, where I don't know how it happened. Maybe it's my prompt is not good enough, but I saw this. I mean, developers do this a lot when they're doing manually coding. Just spot the issue here. So let's say you're building a word counter. You do for each word in document, frequency, frequency is an array obviously, and word is the index, equals frequency word plus 1. So for each word in the document, now think of a scenario where if this is an empty array, of this is an undefined thing, this is going to throw you an exception. It's going to give you a production issue. Because if you code this in your development environment, in your QA environment, sometimes you pre-populate data. So you always have your data in your dev database or QA database. But as soon as you deploy to production, that might be an empty database. So these are the scenarios where this correct approach. Look at this, the same thing, just one single if condition. If word exists in frequency, then only this is not going to throw you a runtime exception. So I'm just showing you with the hash maps approach. These are some common mistakes that developers may do. Looks clean, looks simple, but crashes at the very first item. We call it dead on arrival. So as soon as the customer starts using the software, something happens. But it worked properly. It worked very well in your development environment. I mean, we hear this a lot from developers saying, it worked in my machine. But as soon as we give it to QA, it fails. So these are the things that you should be careful. Again, one extra version for you, this if condition. I can't exactly remember this example. There was a few years back, maybe 2 years back, there was a bug in iPhone where you can search this in Google and it will give you the story. There was a particular wallpaper. They called it cursed wallpaper because as soon as you put that wallpaper in your phone, it started crashing all the devices. So ultimately what happened was that image has more pixel density than the phone's supported model. So, and people, tried looking into this one, saying they started applying different wallpapers, and one person found that if you put that image, that's a very high resolution image. I think it's in a different format as well. So it's because of an if condition. And I know Apple gave a statement as well, and they may fix it in a later release. But what I want to show you is the if condition. We think, oh, it's just a condition, but it's doing a lot. So the real production bugs that I'm dealing with, it's not the very critical items that it's not rocket science, or it's not these heuristics. Everything comes to a smaller typo, if condition, skipping a loop in the unwanted place. So just for information, again, not hash maps, but some extra content. So I added few items here. Most of the languages have built-in ways to handle this. Like in C#, we have this get or default. So in C#, if you are writing this code, if there's no if condition, and if it's trying to loop something, if it's trying to do something like this, it will automatically handle it. But if you are playing with JavaScript, more low-level languages, so this matters a lot. Understanding why it fails make you a better developer regardless of the language. So know the concepts. That's why I think we need to discuss about these hash maps and all this stuff. There's nothing called hash map in Java versus hash map in C#. The concept is the concept. So if you know the right syntaxes and if you can learn it quickly, or just ask Claude, just give me an example between Java versus C# implementation of hash map. So it will give you the comparison. But what I tell you is know the concept so you can apply it everywhere. Don't by heart the syntaxes of a language. So I hope you got the idea of this frequency counting. So the real systems that we use this, right? We talk about word counting and stuff. These are like silly stuff, minor stuff. But really, this is what's happening inside these e-commerce platforms and some of these music and video streaming applications. Cybersecurity, count failed login attempts per IP address per minute. So failed login attempts, they are not going to have a log and start reading. Yep, they are having a running total, running tally. It's like the cumulative frequency if you're from stack background, similar stuff. Web analytics, social media, so everything, social media, especially when you load your Facebook page, I'm not telling directly it's using a hash map, but that's the underlying data structure, what's happening. It's not going to count the count of likes every time. But if you go to your activity log, it will tell you the list review, like this. But from the other party, it's not going to read a log and count while you are scrolling. It always has a saved running total, like we discussed in this frequency count. So these are the real world scenarios that we are using it. Now, this one, I thought of plugging in this. Maybe I'm wrong. What I felt was, with the interns that I had my discussions, I feel like when you are doing your academics, you like to do most of the stuff in the code, but I'm more of a database first guy. So I want to show you in SQL. This can be SQL Server or MySQL or Postgres as well, where we are using this hash map technology. So if you know about what's SQL's group by, it's just grouping. So it's very easy, right? If you want to get a group query, what we do is group by this. But again, if you check the hash map thinking versus SQL equivalent, the key that we discussed is the column that we're going to do the grouping. So I have something in the next slide. The incrementation count is here as count all. The running tally, aggregation is, it's going to do an aggregation per group, and it's returning the full hash map from the select result. So in SQL group by close, hash map is this running total is something that they are using. It's hash map like structure to do exactly what our pseudocode did. So this is an sample for you. Counting orders per customer. So that's the same exact example that we discussed. You have an orders table. Your manager wants to know how many orders per each customer. And this is what you do. And I know most of you guys, when you're going to interviews, you try out SQL statements. That's very good. Whenever you see the word wants to know how many orders placed by each, you know it's a group by, but learn what's happening inside group by as well. That's what I want to give you from this one. So grouping, that's hash map is something that you're doing. So again, when you answer, if someone is answering, if I'm doing the interview, if I answer, what you're going to do, you will say group by. But if you can also say, yes, we will use the group by clause because it's internally using a hash map and it's going to use that technology to group it, that will be an even better answer. So you can stand out from multiple people because I know you know the basics. Sometimes even you forget the SQL syntax, that's fine. But if you know what's happening internally, that's what we all want. So key value, check the important pieces, key value, and group all rows within the same custom ID together. And then order by is just ordering, showing the highest count first. Again, there's some extra stuff with the grouping that you did. So it will return something like this. So this is the exact running total that we discussed in our pseudocode. And I'm going to share some, I do have one C# console application. We're going to go through that. We're going to debug together when it comes to our next last two concepts. I'll share that with you all. Just go through that and expand your knowledge as well. So that has our hash map algorithm as well. I'm not going to go through that one because I feel like these are like basic concepts. So again, this slide is some extra stuff for you, maybe too advanced, because this is all about internally what's happening inside SQL Server. Again, if you're not a fan of databases, if you're a front-end guy, a design person, no problem at all. You don't need to learn everything. If you feel like you're, it's better to have, it's good to have a little bit of everything when it comes to basics, okay? I know some people like to master a particular area, but I'm giving you the SQL Server example because this is something that I work with a lot. So under the hood, now I told you, when it comes to group by, SQL Server does not use a simple hash map inside the group. It uses two specific mechanisms. So it's not just a simple hash map. So if you check this image here, you can see this kind of a four icons. So this is exactly from SQL Server Management Studio. We call this an execution plan. So whenever you run a query like this in SQL Server Management Studio, internally, it's creating a plan like this. So you can search in Google how to view the execution plan, and that's going to show it. So why I added it here is, can you see this hash match aggregate? So this is, I just want to show it is doing a hashing algorithm, hash match, which is similar to our hash map. So whenever I do a group by, this is what's happening. And inside that one, we do something called this statistics histogram optimizes frequency counter. So again, listen to this carefully. We have the hash aggregate. Again, I'm not reading through the slide. You can read it. SQL Server, while it's doing its hashing aggregation, SQL has its own thing called optimizes frequency counter. Look at this. Before you run your query, before your query even runs, SQL Server has already counted value frequencies. It stores this as a histogram inside column statistics. If the histogram tells the optimizer, customer ID has 500 distinct values, mostly appear 20 times. So this helps the optimizer to estimate how many group by rows will produce. So even though our basic concept is there, these tools, like different tools, users its own optimized way of using hash map. So that's in this SQL has its thing called frequency counter. So the ultimate idea is all these newer technologies is based on all these small algorithms, basic concepts that we learn in day to day, mostly that you're learning in your first year. So if you have come up with something like, why are we, I learned something, I learned about these N cursors when I was doing C++ earlier. And at that time, I had this thing where, one of the assignments that I had was, we had to print a cat, image of a cat using stars with looping and all these things in Linux in using N cursors with C++. I really had the question like, in what universe organizations are going to get print cats, right? But it's not the scenario. It's all about they're telling you to practice these algorithms because you have to solve bigger problems when you come to the industry. It's not about, loading data grids and everything. It's about optimizing stuff. So now you all, being university students, you're all coming to a area where AI is, hacking you. Please don't, my advice is please don't dependent on AI. Because I've seen scenarios where even a Git pull, some of the interns, they're asking AI to do the Git pull, typing, can you do a Git pull? I mean, it's fine. Someone can argue it's fine. The tools are there to use. But my problem is, the tokens. But it's okay that you read AI's prompt. But before you apply, you make sure you understand it. So that's the whole ask. Don't just say, AI created it. AI did it for you, it worked. Don't say that, because otherwise, if there's a problem related to optimization / performance / non-functional requirements, it's very hard to debug. So that's why I want you to, learn about these things, basics, know what's an execution plan. If you like to work with data, it's a must. You should know what is an execution plan, because while looking at that plan, you can take decisions on, okay, why does it 7%? How can I reduce it to 5%? And then, reduce this 9.476 milliseconds to 5 milliseconds. So it's actually seconds, it's burst. If it's milliseconds, that's fine. So this give you a very good advantage in the production, because we are not talking about 100 customers, we are talking about thousands of customers hitting the same table at the same time. So this really matters. So that's all about hash maps, and I wanted to show it to you. And again, some other stuff with SQL. We don't need to spend lots of time on this one. It's about, group by applying to multiple aggregations doing at the same time. I do have something called how many orders per customer. It's very simple, straightforward, group by customer ID. And here, I'm doing some operation as well by group by, and then here I have a bunch of other aggregation functions like sum, average, using max with group by and order by. So ultimately, all these are going to use hash map technology, because it's not going to calculate everything at the same time when you run the query. So as a summary, again, forget about all the hard stuff. It's your scoreboard. Think of the scenario where Jazuri is 423 in my image. Go through you're going through the data once, maintaining a running tally, and that's the hash map, used as a hash map. So the algorithm is simple again, even though you have array lists and stuff. If the key exists, increment. If no, initialize at 1. Again, once you initialize it, if you come back here, now your key exists, okay? If it's no only, you initialize at 1. So look at that, like the whole algorithm is now in one single line. So just just remember this. That's what a hash map is. And the bigger notation stuff, again, these are mainly from SQL. Group by is frequency counting built into the database engine. and it has some other aggregations, and these are the real world scenarios that we will use these hash maps. Okay, so now we are coming to our second topic. And again, if you have any questions, feel free to drop it in the chat, okay? If we don't have time today, I'll definitely reply back, but feel free to use the chat to drop all the messages. So hash maps, frequency counting, that's that. And then now we are going to talk about something called this prefix sum and efficient range processing. So what is this? And the example, whenever you open your banking app, right now in your head, and you open your monthly summary, you will see the January's total, February total, how's the spending. I saw yesterday in the Nation's Trust banking app, and now they have a nice pie chart as well saying these are my expenses, and they start adding AI stuff as well to advise some stuff I don't like. So every time I open the app, they have a running tally. They have a spending summary, and it's going to show us all the totals. And it's not just for me, it's for all the customers. And all these people may have billions of number of transactions. So adding all of them every time when you press the buttons, it might take too long. So that's one of the problems we are going to resolve here. So you may feel like the hash frequency counting and this is similar, but yeah, let's dig in and see what's the difference. So if you just go through this, your account has thousands of transactions going back to years. The bank didn't add up all these transactions in real time when you do a refresh. That will be too slow. So they pre-compute the answers. So this technique we call prefix sum. Okay. So without the prefix sum, again, we'll go with the same flow. Think you have an array of daily sales figures for, this number of years. And you're asking the question, what's the total sales between day 50 and day 200? So now this is the difference. Okay, earlier in the hash map, what we did was like we kept a running total, but in this scenario, now we have a different where clause. We are just asking from the middle. From this to this, give me my total. Earlier scenario, it's like having a running total, not like this. So that's one of the differences. So this is the simplest query. What you can do is initialize your total to 0, the variable. From day 50 to 100, it's a for loop. You just add your total here. And you may read this 50 from somewhere. Again, this is a pseudocode. This may involve some other codes to read what's the value from 50, 51, 52, likewise. So if you have to answer 1,000 such queries based on same data, it's 150,000 and it becomes 150 million. Now, this is the trick, okay? The data never changed. Now, you are just asking questions from the existing data, which never changed. Now, in the earlier scenario, running total, we can say the data changing, but whenever it's changing, we keep a running total. But in this scenario, you are just recalculating from scratch every time, which is a huge waste if you are doing this. So that's why it's a co-waste, repeated work on unchanged data. If it's changed, fine. At least we have an excuse. But this is so there's a smarter way to handle this. That's what we're going to discuss this. The prefix sum, we also call it a cumulative sum. So this is a pre-computed array. And we say, what if you pre-compute the cumulative totals from the very beginning? So position 1 holds the jump element and position 2 holds the sum of this, like this. Now here you have 4, 4. 4 and 2, it becomes 6. 6 and 7 becomes 30. Again, when you look at the slide, it's very simple, right? I mean, it's very simple. Why are we even talking about this? But we have to tell this to the computer, right? So always think that we have brains, we have brain power. How we know that four and two become 6? Because we learned it for the last 10 years. And we know about the cumulative frequency when we are doing graphs and stuff, right? So computer doesn't know anything, so we have to build up an algorithm to tell it. Whenever I submit my data set, you have to do this in order to make it efficient. So what we say is, do the work once and answer infinite queries for free. So if we build up this thing, now if you ask me, yeah, I need the total between 7 and 5, what I have to do is, what is it? Like, I know exactly by looking at the prefix sum. So let's go through the mental model. Think of like an odometer in the car, the speedometer. So car's odometer, total resistance driven from the beginning. Now again, if you just read the first statement, you will feel like, isn't this the hash map that we just discussed? Now read the second and third one. Now here we are talking about a difference between two. Now just say you are going from Colombo to Kandy. Every time I do this calculation when I'm doing, just to see whether how much fuel I wasted or consumed, not just wasted. So this is what you're doing, right? If your odometer reads 45,200 when you left Colombo, and by the time you arrive at Kandy, and this is it, the distance for the trip, you calculate it. You didn't measure by the road by kilometer to kilometer like we did in our first example. We just subtract by using 2 indexes in our array. Well, that's what we're going to do next. So you just read the 2 numbers and you subtract. And this is exactly how prefix sum is going to work. So now, if I go to my earlier thing, hash maps algorithm is, if key exists, increment, if no, initialize. Here, any range of query equals read 2 questions, subtract, and done. So that's the difference between these two. Again, very basics, but doing a huge impact when it comes to production systems. So this is it. Again, mathematically, it's nothing, okay? There's nothing to understand here as a human or as a student. But the trick is, yeah, telling this to the computer, as I always say. Because that's why, again, not sure whether you know, you must have heard about the Crook's-Hall's algorithm, right? Crook's-Hall algorithm. We use it to map the shortest distance or find the shortest distance. And again, I don't know whether you heard this. I think it's 6 to 7 months back. A team of engineers found that. I mean, I learned when I was doing my BSc, Crook's-Hall algorithm is the most efficient. But they found it. No, it's not the most efficient with all these AI and stuff. They found, no, there's another algorithm that can get the shortest path. So that's why I'm saying, since I learned about Crook's-Hall algorithm, okay, I know I'm going to apply it here, but if we learn a different way, right? Some people are there, some small kids are there who can even there are people who's listening to you in this lecture, who can, quickly add and subtract numbers. They're using different methods. So with the computers, this quantum computing, AI and stuff, what we do is, yeah, we have this very basic thing that we thought this is the most efficient way. And whenever we are feeding this to computer and, engineers start researching this, and you guys will do it, and please do it. Try to break these systems and find out a new way. So the basics are the ones that we are discussing here. I mean, you will feel like why we are even discussing something, but that's the basic algorithms that all these systems developed on top of. So think of this: original data, daily sales. You have 7 days. These are the sales. So when we are building this prefix sum array, initially it's a 0. Now we are building the prefix here. The first prefix is 0 plus 1. Second prefix is 1 plus 2. This comes here, 1 plus 2 again. It's the cumulative frequency, cumulative total. And now we have a pre-calculated array here. So now if you ask from me, give me the sum of the data between 4 and 7, you know exactly where to point and do the calculation. So look at this. Now we already have a calculated one. We are not doing the calculation again and again. So answering range queries, the formula is sum from the day L to R, prefix R. We have the array, prefix R, this is the array index minus prefix L minus 1. And I hope you know why L minus 1. It's because array starts at 0. So it's so nice names regarding this, right? So if one person, some person said if he becomes the president, they're going to start their index at 1 or something. So funny stuff, but minus 1 is that, okay? Because if you have these kind of questions, why it's minus 1, please check the basics again. It's because array starts at 0. So look at the example questions. Total sales from day 2 to day 5. What we're going to do? Prefix 5 minus prefix 1. So 5 means R, 1, because 2 minus 1 is 1. We get the data, we deduct it. So this is the final verification. So quickly, we can do it. Now again, go to the place where we try to do this with the conventional for loop. This will work, okay? It will work for 10,000 or even 100,000 records in milliseconds, because computers process this a lot. But when it comes to millions and billions of entries, it's creating a huge problem. So that's where, you know, when the production problem hits, what we are doing these days also in the industry, yeah, let's go and check the code. And we find that, okay, there's a more optimized way to do this. And someone is doing this. And whenever I ask from Claude, okay, is this way, is it okay? Can you do a proofreading? It says, yeah, this is this particular concept. So you will face into such scenarios, okay? There are lots of concepts, lots of names, the basic stuff. So this is how you fix this kind of problem. So we answered the range question. So the whole logic, what happens is, again, build once, query forever. First of all, you have to build the prefix sum. You have to build it first. And again, if you're, now let's say you build it and your array is still adding stuff. Now, if that's the case, what you can do is, yeah, do a nightly job to build the prefix sum. So you have a data, or just every time when you do the order, like we discussed in the hash map operation, if you are dealing with an array, do it at that time. But I don't know, I don't have a recommendation, because based on the system to system, based on the frequency of usage, this can differ, and based on the client requirement, this may differ. If one of your client is asking, I have data every 24 hours, you know, we are processing 1 million rows, and I only need to see the sum tomorrow, not the real-time sum, but if I can see the yesterday's sum, that's fine. So in this kind of a scenario, you can simply use a nightly job. But if your client says, no, I need to see the real-time value always, like what happened in the past second also, then you may have to think of a scenario where, okay, every time when we do a data change, should I update my prefix sum? So I don't have a direct answer, because all these things are based on the conditions that your customer says, that your system says, that your infrastructure provides. So the idea is, yeah, prefix sum, you do done once, and then this is the query, you can run it. So you build it for each query to lookups, one subtractions, even for 1,000 queries or 1 million queries, when you're getting the value, it's just a very quick operation. You are not going to calculate anything. So the loop each time, first per query, versus prefix sum, first per query. So we can check the numbers, because again, numbers matters when it comes to industry. Every operation is a cost. Every operation is a depreciation of a machine. Every operation is a, when we are talking about, cloud a lot these days, and that's my specialty area as well. If you host this in a DynamoDB instance, per query, you have to pay. If you host this in a PostgreSQL table in AWS, there's a one-time cost, one-time recurring cost per month. So operation count may not matter, but still, if you are surpassing some kind of operation, you may have to pay extra. So likewise, you have lots of considerations. The best way is always try to make your code effective, less number of operations. And one other thing I'm more interested these days is sustainability, right? We all use, ChatGPT and Claude. Any of you thought when you are asking to, I hope you're not doing this. If you're asking to do an assignment, or let's say the positive way, if you're asking Claude to review an assignment using Claude, any of you thought how many carbon emissions is it going to emit? Because of this, how many damage that I'm doing to the ozone layer? How many trees, like how many water liters got evaporated because of the heat that generated by processing my query from this particular data center. So think of those as well, because that's the next phase that we are going into, because AI will start coding. We have to talk about, the other aspects. So that's where this comes into. Go with prefix sum. Save the tree, save the planet, simply. So real systems that use this. So where prefix sum in real products, okay? See, mainly this banking and finance, business intelligence, and if you're a fan of stock market and stuff, then it's made from the ATRAD portal, lots of numbers. So they're using these cumulative trading volumes over time windows. So these are some of the real world systems that uses these. Internally, you will feel like, it's another where query, right? It's another where clause, it's another if condition, but internally, inside the where clause, inside the for each loop, these are the things that's happening. So when it comes to SQL, we use this running total a lot. So we have this query called over. So if you're going to build the prefix array, just use sum and over. You have to order by whatever the parameter, and each row is running total, that's the previous, and you can query the range by just subtracting two totals. And this is a sample query that you can see this cumulative sales. So daily sales tables show each day's sales and the running total up to that date. So internally, you can write a CTE. If you don't know what a CTE is, we have something called common table expressions, which is kind of a loop. You can do the naive way where, looping each and every time, or you can use the over, like whatever the SQL server's inbuilt function, which is really optimized using internally these hash functions and these methods, which we'll do internally. So again, this is just for you to know internally, this is what's happening when we are doing this cumulative sales using this over keyword. So what is this? This is the SQL equivalent of prefix January 20 minus January 9th. So this is the same thing that we saw earlier. I think daily sales table. Yep. And then I'm doing a select. When you do the max function, whenever the sale date is this one, then cumulative sales date end. So this is again the SQL's way of doing it. If it's C#, if it's Java, the syntax may be different, but internally, what I want to explain is this is how it's happening. The range sum query, how we are doing it in real world in SQL. Again, I like to talk about SQL because it's closer to data, okay? If you are doing this calculations, again, one more thing, all these concepts, these are like back-end heavy, I would say, because if you are doing these operations in a front-end application, like let's say, if you're doing this in JavaScript, for a smaller data set, that's fine. But if you're doing very big stuff like, this heavy stuff in a browser, that may work for one customer, that may break for another customer. If we are using a machine with very less number of RAM, browser, we all know that Chrome and it eats the RAM. And on top of that, you are giving one of these functions as well to do in the front end. It'll create chaos. So why I selected SQL is it's more closer to data. Even if you're doing this in the API layer, totally fine. But in the database layer, if you can do it, like it's more closer to data. That's why it even shows SQL. So that's that. And prefix sum, this is the summary. Again, we have the core idea and the algorithm. It's two parts. You have to build it and you have to query it. But in the initial one, first one, there's no two parts. It's always we are keeping a running total. And why it's fast, SQL, and the real world, you can read it when I share the slide deck. Okay, so for the third and fourth items, even though I have slides added here, I want to debug this with you. I do have an application ready with me. Yeah, I want to debug this together. So let's first go through the theories. Now we need to discuss about this two-pointer technique for optimized traversal. So again, even I hate these, big words. I'm a person where I want to understand the real world scenario. Then I'm going to map my brain into, okay, that's what's happening here. So two-pointer technique for optimized traversal. So what's happening here? So we all use dating apps. If you haven't used, start using it. So what's happening is it has millions of users, each with a compatibility score. I don't know. I really don't know about the compatibility score feature. Like different applications may use different methods, but my idea is how these applications doing these matches so fast. So what they're doing is, when you open the app, it instantly shows you matches within your preferred score range. I mean, you may add your preferences. I like to do this and that. I'm a person, I'm a foodie, and someone might say, I like, traveling and climbing mountains and stuff. So based on these numbers, based on these things, they may add a score and they add it. And even for those adding, they might use these earlier techniques that they're using. It doesn't check every possible pair of users against every other user. Because let's say you have millions of users, just to match your profile, I don't think they will do a normal neighbor algorithm. So that's billions of combinations. So it's a very dumb way to check every possible pair, right? You take your profile, you match with someone else, take your profile, match someone, in your location. So instead of it uses clever traversal, moving from both the ends towards the middle. Now this is what we call two-pointer technique. So you have an array, you are going from one end to another until you find something. So again, the classic way of doing it, the dumb way of doing it, find the two numbers in a list that adds up to a target value. Exactly, this is what you're doing in a dating app, right? Two numbers, two candidates, we both have a target value to find out what's the common stuff. So there's a score for the common stuff. So this is what you will do. And this is what this is. Lots of loops. For loop inside a for loop, and a bunch of stuff. And I reviewed one of the codes on one of the legacy Visual Basic applications few months back. And I saw, again, I'm not saying that's a bad code. At that time, even though these concepts are there are places where people use lots of nesting inside loop. I mean, loops inside a loop inside a loop. I mean, someone can argue based on the business context. Yeah, that's valid. Yeah, I can agree. But having lots of loops like this, forget about the performance. It's very hard to read, and it's very hard to debug even. We don't know from where to where it's going to jump. So if you're saying, even in your code, if you have nested loops, unless it's very specific for a particular workflow, just revisit it. See where you can optimize. Grab the code, put it into a function. At least do it in a recursive function than doing stuff like this. Because I don't know from J to I when it's going to jump and stuff. So that's why it says in this method, every element, check it against every other element, right? So I don't want to even count the number of zeros here. So it's not scaling. And again, it'll execute, okay? You can do this, in your project. It'll work, but we are talking about the real production grade stuff because these may fail in production. Can we solve this by going through the data only once? Now, that's what we are going to do. So introducing the concept, what is two-pointer technique? So you're placing the 2 pointers at different positions in your data, move them toward each other or in the same direction based on a condition. Again, I'm going through this one because we will debug one application. At each step, make a smart decision on which pointer to move. Now, look at this. Move them towards each other. And when you move something, you don't know like what's the decision to take, which pointer to move. You have two sides, left to right, I mean left and right. Who's going to decide this time I'm going to move left, this time I'm going to move right? So continue the point until the pointers meet each other or the answer is found based on the sorted data with a clear ordering. Lots of theories. Let's do the debug and see. The main two variation is this one, opposite ends and same direction. So yeah, let's go through the theories and then go to the practical one. So the mental model is here. So think of it like two people walking towards each other. So still, I want to go through this one, but why don't we quickly jump into our practical thing? Let's discuss. We will do the same thing, same mental model when we debug. So the core logic. So again, this is the algorithm. This is the pseudocode that we have. Okay. Now I have yeah. So all these things. Real system topic. All these things. Let's come back to this after we go through our application. Okay. So I'm going to run this application and I'll share this with you all as well. If for some reason it messed up my. Okay. So I created a small application and I have the hash map and prefix sum algorithm as well. But since those are very straightforward, I'll quickly go to 2 pointers. So while debugging this, I'll tell you what we are doing. So here I'm using a small C# application. So it's a console application and I just added a breakpoint here. And I added a small note for you guys as well. So let's debug this. Let's go through one by one using F10. And let's go inside using F12 and see what's happening. So what we are going to do is we have a sorted array of numbers in plain strings. We have the left pointer and the right pointer moving towards each other to find the pair that hits the target. Now, what's the target? What we are going to do is the target is 13. To sum of on a sorted array. I'm going through this array. I want to find out adding what two numbers, it's going to give me 13 in the most effective way. Okay, so let's go one by one. And you can see my console here. So I have an array. Again, use these tools effectively. And again, I've seen students, I've seen interns there who does not know how to debug. Okay, that's a very sad story. Debug is all about putting a breakpoint, or just use console.write lines and traversing through what's the current number. So that's what you need to know. So I have a sorted array. This is my array. I have a target, which is 13, an integer variable. I just print these two. This is my sorted array and the target sum. Now I'm going to, I have integer L and integer R left and right, and I'm going inside by pressing F11 to this toSum sorted function. So I'm passing my sorted array and my target as well. So I do F11. So now this is where we do our two-pointer technique. Now this is in C#. So let's go one by one. So first of all, I'm using this array.sort method, which is an inbuilt feature in C#. I'm passing the nums array. My array is already sorted. So if it's not, it will sort it. Okay, so I have left is 0 because my left point is left index is 0 in the array. It's not going to change. The right is, how can I get the right? I have my array. I'm using the length function. I'm getting the array length. So 8, since we are starting from 0, minus 1, now it's becoming 7. Okay, now I'm going inside a while loop. So while left and right. So left is 0, right is 7. Left less than right, yes, it's true. I'm going inside the loop. Now here I say in sum, nums left. What is nums left? Nums is my array. Left is the index. So what's the value in the 0th index? It should be 1. Here it's 1. And I'm adding to nums right 7. 7 means 15. So 15 plus 1 is 16. Very simple. I go to the next section. I'm checking whether 16, sum is 16, is it equaling to my target, which is 30? No, it's not going to equal. Because of that, it's not going to the return statement. It went to the else if. I'm checking. My sum is 16. It's the same thing we calculated. Whether it's less than the target. Target is 13. Sum is 16. So what is happening now? That's wrong. Because of that, I'm going to the else statement. Now I'm doing a right minus minus. So we can say right minus 1. That's the same thing. So my right was 7. As soon as I execute this, my right becomes 6. This right minus 1. Okay, now this is the place where we discussed. I'll make this bigger. This is the place where we said here. Oh, where is it? At each step, make a smart decision about which pointer to move. That's the smart decision we are taking. Okay, now we decided, yeah, we need to do a right minus minus. That means coming from here, based on our condition. Now I'm going through the left. Again, 0. We didn't do any changes to the left. And what is our right? Right is 6. Now, if the array is not sorted, this is going to mess. So that's why it says always sort the array before that. Now my sum, okay, left was 0, same thing as 1. Right now becomes 6, not 7. 14 plus 1 is 15. Now my sum is 15, my target is 13. Still, this is going to break. So it goes to the else if. Now my sum is, what is my sum is 15, target is 13. 15 less than 13, again, it's a failure. Again, going to the else part. Again, I'm reducing from right. Now right becomes 5. Now next time I'm going to check 1 and 9. 0 and 9, so 1 and 9, what is it? 9 plus 1, 10. My sum should be 10. Sum equals the target, no. Now sum less than target. Now this is going to get true. 13 is higher than 10. Now I do a left plus plus. Now this means, now so far within the last 3 steps, we moved right. Now I'm going to move our left. So it's not going to the left, it's going to the else if. Okay. Left is 1, right is 5. Left is 1. 1 means 2 because 0 and 1. 1, 2, 3, 4, 5, 6. Now 9 and 11. My sum becomes 11. Is the sum equals to the target? Still no. Again, if go to the sum less than the target, yeah. Now left plus plus. And again, moving my pointer here. Okay, again, left to right 5. What is left 2? Left 2 means 4. Right 5 means 1, 2, 3, 4, 5, 6, 9, and 4. 9 plus 4 is 13. Now our target is also 13. Now this if condition is going to get true. Sum equals 13, target equals 13. It's going to return. Now as soon as I return it, it's going out my sub function coming to here. Left to right 5. So that means it found the combination 4 plus 9 is the easiest way that we can get 13 from this array. So that's the quickest way that we did it. Now that's the same. So I can go down here because I have some other examples for you all. The palindrome check, right? Again, is the most basic programming question that people ask. If you don't know what a palindrome is something where if you can do the same, spell the same word, race car, can you RACECAR backwards? RACECAR, that's a palindrome. Race car is a palindrome. Hello is not a palindrome because H and O different. Madam is a palindrome, world is not a palindrome. So that's also based on this two-pointer technique. So I have a few other examples as well. You can go through this. I'm not going to go through everything. Race car is a palindrome. So again, we are using the same methodology, same way to calculate these. And then I have another example to find the duplicates. Now here also, we are doing the same thing. We are coming from here to here, here to here, and finding what's the most optimum way. So I'll share this application as well with you all. So hope it's clear. Now, we continued until the pointers meet or the answer is found. That's what we did. We met our if condition was successful. It's true. And it says work best on sorted data or data with a clear ordering. Yes, so that's why we sorted it. This is the same thing we did there. And this is exactly how our two-pointer technique works. So I'm not going through one by one again, and this is the exact thing we did. So, and that's the most efficient way. And again, as I mentioned, this may not be the most efficient way as per the Prefix-Sum algorithm, right? One of you guys may find out, okay, that's wrong. What we learned is wrong. There's another way. There's another way that's possible with quantum computing to find out. Because, lots of data structures are there that's happening, based on different data. Sometimes this may be the most good way for strings and arrays, but for document scanning and searching, for image processing, this may not be the most. I'm just giving you an assumption. So find a way. That's why I love about these basics. It's not always about fixing a business problem, but it's eye-opening for others as well. So if you don't understand any algorithm, even the bubble sort, selection sort, these stuff, the best way to learn is, as I just did, just do breakpoints, go through the algorithm one by one. Try to change the condition. See whether if I change the equals, what's happening. If I do a minus, what's happening. Where to break it. So do those stuff. And this is the pseudocode. And this is again the walkthrough example from our PowerPoint presentation. So same thing what we did, we moved the pointers and find out. Very less number of comparisons. Again, if I tell you, using the lowest number of comparisons, that's how you do it using this two-pointer technology. Now again, same thing. So the same thing that we discussed, palindrome versus remove duplicates from a sorted array. I just added the two pseudocodes here as well, but you can try out the application. And real-world systems that use this. So we are not going to always count the palindromes, right, in real world. So search and matching, as we discussed, dating applications, and when it comes to price range filtering, so products between 1,000 and 5,000. Bioinformatics, like databases, we have this merge join in SQL. This is what we use mainly. We are checking whether that's, we want the most optimum way to do it. So we're using this SQL engineers use a 2-pointer style merge. So that's the algorithm that's running behind. And our 2-pointer summary, again, I'm speeding up because we have a time limit as well, and we have one more algorithm to go through. So we can go through the items that what we learned. Now, learn about this small 3 points that I say, the algorithm. We start at left and we start at right at the end. How we figure out the right? We take the array length -1, and at each step we have that if condition, whether who is larger. Based on that one, you decide whether to move the left pointer or the right pointer. Okay, so the fourth one, or the last theoretical one that we have, is this sliding window for real-time computation. So what is this? So this one, again, I want you to read the items that I added here. How does Netflix know your connection is buffering before you do? And even YouTube does this, and even WhatsApp does this, right? And sometimes Teams and Zoom, they're doing, they're checking our connection and telling, you may have to turn off your video because you have less bandwidth. So switching to audio call will be better, kind of a thing. So internally, what's happening is it tracks your download speed over the last 10 seconds. I mean, this is Netflix scenario, but ultimately what's really happening is it's checking the data in our array. So again, we'll go through the dump way of doing it, okay? The problem without sliding window, if we don't have it, if you are monitoring network speed, every second, you want the average speed over the last 10 seconds. Let's say you have a calculation. So you have to update each and every second. So the naive approach is every second you loop through the last 10 readings and compute the averages. So that's 10 operations again. How we have sensors related applications, 1,000 into 10,000, 1 million. So every time a new reading arrives, you recalculate everything from scratch. And again, what if your window was 1,000 seconds instead of 10? Now it's 1,000 operations. So in sliding window, what we are doing is it maintains a fixed size or a variable size. It's not always fixed. It can be variable size as well. But in this scenario, I say, I'm only checking the last 10 seconds. Variable can be, different business scenarios, but in the fixed one, let's say, whenever the new data arrives, the window moves. So instead of recomputing the entire window from scratch, we just remove the last one, kind of a first in, first out methodology, and then we are adding the latest one, and we recalculate only for the newly added item. So we are updating our running result with this small adjustment. So again, mental model, think a stock chart. Let's say we have a 7-day moving average. For each day, it averages the price of the last 7 days, 1, 2, 3, 4, 5, 6, 7. When the 8th day arrives, the first day leaves from the window and the 8th day enters. So the new average is the old sum minus first day's price plus 8th day's price divided by 7, because our window size is 7. That's it. This is our algorithm. So the line chart moves smoothly forward and the window slides. Now here, the logic in pseudocode, it computes the maximum sum of 3 consecutive elements. So why don't we try that as well in our application? So what I'm going to do is, why don't we switch to, let me restart this. I want to go with my sliding window example. Okay. So I have an array and my window size, which is k variable, is going to be 3. So what I'm going to do is, my goal is maintaining a moving window over the data, expanding and shrinking it to find the maximum sub-array sum of fixed size k, the longest substring with no repeated characters, and the smallest subarray whose meets the target. Lots of text. Again, why don't we move this? Okay. So number one, I do have an array, but even though I have 1, 2, 3, 4, 5, 6 elements, our window is 3. So what we are going to do is we are going to move. First, we are going to take 2, 1, 5, and then do a sum, and then I'm letting 2 go, 1, 5, 1, and then it becomes 5, 1, 3, likewise. So I'm writing, yep, my array is this one. Okay. I came to this. Okay, I did F10. I should come here. Oh, my bad. Let me restart this. My choice is 4. And I do F10, F10, and here, actually what I'm going to do is, I'm not executing the console.writeLine because I have this function inline to calculate the maximum sum fixed window. So I do F11, and now I'm inside my sliding window algorithm. So what I'm going to do is, initialize the window sum. It's 0. We haven't even went through our array. So our input parameter is the array and the window size. So I'm first checking whether I less than k. That's true. So the window sum equals. So I'm just going through my array and bringing out whenever it's becoming my equaling to my size. So that means 1, 2, 3. And then here what I did was like I calculated the sum here. So that's what I did here. Sum plus equals means, it's adding. So my sum is 5 plus 2 plus 1. It is 8. It says max sum is 8. Now I'm going to slide the window. So my initialization is here, and until the num dot length, I'm going to go through the loop. So I'll just go through this quickly, and what you can see here is max subarray size. So based on the 3 window items, the maximum sum that we could get was 9. So that's the output of this. And then similar other applications that we have is this. I do have this ABC, AB, CBB. So we have the string, longest unique char substring. So that's another substring. And then again, minimum length also I calculated using the same algorithm. So we go here. I just want to walk through by going through this example here. So I have the array and my window size is 3. The goal is maximum sum of 3 consecutive elements, which is the same thing we did in our algorithm. So we start it with 2, 4, 7, no leaving and no entering. So the initial sum is 30. And then we throw away, we are throwing 2 away, and 4, 7, 3 becomes, so 2 is leaving, 3 is entering. And we do the sum, it's 14. So we are traversing through the whole array and then finding out what's the max. Now again, forget about the theories. Apply the same thing to an example like this. So the rate limiting is my favorite example. So whenever you subscribe to these, free APIs, free applications, whatever free, they have some cap call, you have 100 requests per 60 seconds. If you have used the SendGrid free version, SendGrid is a tool that we can use to send emails if you don't know. So what they're telling is per day, they're giving you 100 emails. So within the day, they are checking whether how many times that I use the emails. So again, in IoTs and sensors, if you're going to calculate the average, when it comes to average, you need to go through all the batches. But when you're going through all the batches, you don't need to process all the data. You just remove one away and just getting the new entry. And the computation is very little than processing it every time and getting the value. Same thing with financial systems, same thing with network monitoring. So whenever your window updates, you only calculate for the updated window. So that's what we all discussing about these variables. This work through example. You're not calculating for the whole thing. You're not calculating for the whole array. Whenever you get a new item, you just move it. But the window size matters, okay? That you have to decide whether, based on your requirement, what's the window size to stick with. So there can be a variable size windows. Now we discussed about the fixed size. So if it's variable size, find the smallest window subarray that sums to at least a target value. So in this scenario, our array changes, you can see expand window right after. So there's a code segment to expand the window as well based on the logic. So with sliding window, you can try out both the scenarios. So again, ultimately, the core idea is maintain a window over sequential data, slide it forward with minimal recomputation. Anyone can do this by processing the whole array, but we are talking about the minimal recomputation. So again, I don't know whether if you're a fan of the NVIDIA creator. So I saw they released a quantum computer for $250, which runs, I think, 1 trillion or 10 trillion operations per second. Now that's all. Anyone can do coding, anyone can do computation, but minimal recomputation, maximum efficiency is what we are looking for these days. So that's why these techniques matters a lot. And someone can say, I can do the same thing with just a few, bunch of loops with some if conditions. But again, as I mentioned, when the data count is higher, you're processing 10,000 rows versus you're processing 1 billion rows. That's where the difference comes. It will work for 10,000, it will work for even 100,000, but the data size is more. Then the recomputation means, as I mentioned, it's a cost. It's a monetary wise, it's a cost. CPU depreciation wise, it's a cost. So, and again, now nature wise, it's a cost as well. So learn about all these basic concepts so you can see how you can do your software with minimal recomputation. So we are moving to the last one. Again, this is more of a back-end one, more into databases, this row number concept, ordering and ranking. I just added this because I want to showcase this because we are using these functionalities every day in business critical applications. So the row number concept. So there are a few ranking concepts that I want you to see. So what is this row number? Again, if you go through this, you'll say online games like PUBG, Free Fire, Call of Duty, chess.com, they have this leaderboards with millions of players. And after every match, the rankings are going to update. Again, one of you can say, isn't it just getting the sum of the rows? Yep, it is just getting the sum of the row. But if you're using some functionality, they might be using row number inside. But if you are going to write your own algorithm, if you're using bunch of for loops for each loops, it'll degrade performance. So that's where this row number concept comes into picture. So let's say you don't have the row number concept. So problem without structured ranking. Again, the same slide you saw, I'm showing lots of numbers. You can simply rank 1,000 employees by their sales figures, show their rank within their department and their overall rank. So 2 rankings. You can simply sort all the employees by sales, get the overall rank, and then as soon as you see for each, it's a loop. for each department, because we need to get the department rank and overall rank. You filter the employees by the department. Again, you have to sort to get the department rank, because now it's two different scopes. If you have 20 departments, 21 separate sorts. Yes, because per department, now you have to sort. So again, we are seeing lots of zeros here. So the real problem is, if someone wants to be ranked by the region, product category, by quarter, bunch of other parameters. So every approach requires separate sort and separate group. So that's where these three ranking concepts are coming into place. So you should know what rank to use at what problem, or when you're trying to solve what problem, what function to use. So again, this is, you can see, you can't find this in, Java or C# specifically saying row number, rank, and desk rank, but this is more comes into the structured databases. Again, you can find this in SQL, MySQL, SQLite, and Postgres. So the three ranking behaviors, row number, no ties, always unique. Again, we are not going to go through the implementation behind rank number, but in the fifth one, what I want to show is some of the functionalities it might do. You can do the same row number functionality, you will do it with rank, but look at the type. If there's the same rank, if you use the rank function 1, 2, 2, if the same person gets the same number, their rank becomes same number. With the dense rank 1, 2, 2, 3, 4. So here it skipped 3 because we have two 2s. Now, if you are building a athletic scoring application or something, if you use rank function, and because you have two like number 2s, second place have 2 people, you can't say third place is not there, right? That'll be a problem. So that scenario, you may have to go with the dense rank, because there can be a scenario where same person gets gold, same 2 people gets gold, 2 people get silver. That can happen. Ties to get the same rank, next rank doesn't skip. So based on the requirement, the ranking, ordering, sorting and ranking / ordering can get different. So again, mental model, think like when the exam results comes out, overall rank can be the position among all the students in the faculty. You can have a department rank and you can have subject rank as well. So without structured ranking, you have to run a separate process for each ranking type. And that's separate operations again. So in the overall ranking and the partitioning ranking with ranking groups, these are the two pseudocodes that's mainly happening. You can see this is very straightforward overall ranking. And when it comes to partition ranking with groups, we are checking whether is this rank already in the current group. You have a bunch of if conditions here. The same thing here. Data and Alice, Bob, Carol, Dave, and Eve. Department-wise, the row ranked 1, 2, 3 within the department. Department B, rows ranked 1, 2 within the department. Now our counter resets here. So overall rank comes from a separate sort by, which is a sales rank. So that's a separate sorting. So we can see in this scenario, Alice becomes the first, but in this scenario, Bob becomes second, but in here, Carol becomes department-wise, the rank is going to be second. So the whole idea is, again, to learn about the differences between row number, rank, and dense rank. And if you haven't heard about these things, just search it, and you can use these effectively as well. So again, same thing in an explanation. I'm just showing you. When it comes to row number, it's going to ignore ties. 95, 95, 80, 75. Arbitrary tie breaking, always sequential. Okay. This person can come and ask why I'm second, because I have the same score. So the question is, the designer might ask from you why the system interpreted it like this. You can't blame the system because you used raw number. In that scenario, you have to use rank function, not even rank actually, the dense rank, because if you use rank, number 2 is not there. So you have to use the dense rank, which honors ties and no skipping. So this is the correct way. 95, 95, 2 first places, 1 second place, and 1 third place. This is wrong because there should be a second place as well. So finally, and we can wrap up the session. So these are the 5 concepts that we discussed: hash map / frequency counting, prefix sum, 2-pointer, sliding window, and finally this raw number / ranking functions. So there's the big picture. So everything that you learn here, as I mentioned, ties to business goal, business objective. It ties to money because someone has to pay the developers. Someone has to pay for the infrastructure. Infrastructure cost means if you have a less efficient system, your cost is more. So if you want to make your systems more efficient, please use these basic concepts correctly and apply it accordingly. So sometimes there's no correct answer when you ask a direct question, but I need more inputs on, okay, what kind of a problem you're trying to resolve? What's the customer's budget? What kind of a machines that we are going to deploy? So all these comes into questions, answering questions when it comes to these concepts, but the basic functionalities like don't use lots of for each loops, don't use looping mechanisms because we already have these kinds of concepts, algorithms, so you can use in your projects. So that's mainly it. And again, you can find me on LinkedIn. If you have any specific questions, please reach me out, drop me a message. I'll be happy to answer. And if you have any SQL Server, Azure cloud computing, if you don't know what's your path, if you are lost, even though you're pursuing an IT degree, if you don't know where to go, again, ping me. I'll be happy to help, very happy to help, and want to unblock whatever the questions you have. So that's all. Again, thank you for listening, and I'm handing over to Damitri or Astra. Over to you.
All right. We'll now move into the Q&A session. If you have any questions, feel free to drop them in the chat. If there are no questions, we'll proceed to wrap up the session. Before we wrap up, just a quick note on attendance. We'll be sharing the attendance form in the chat now. Please make sure to use the same name across Zoom, the attendance form, and the quiz. This is important for checking your performance and issuing digital credentials. If your Zoom name is different, kindly rename it now. Only the submitted forms will be counted for attendance. And before we move on, we'd like to sincerely thank our speaker, Mr. Harsha Weerasinghe, for taking the time to share his knowledge with us today. It was a very insightful session. As a small token of our appreciation, we'd like to present this in recognition of your contribution to Algo Ace 2.0. Now coming to the session challenge. The quiz for this session will go live right after this. It will include 10 MCQs based on today's content, and it will be open for 1 hour only. Please make sure to use your registered name when attempting the quiz. To keep things fair, we'll be cross-checking the quiz responses with the attendance details before final evaluation. Your performance will directly contribute to your overall ranking and badges. Now, I'll invite Devami from the program committee to guide you on how to access and attend the quiz.